Have you ever had to figure out who won a tournament? You've got a list of matches, a list of results, and you got to find the champion? It seems simple, right? But there's a slow way to do it and a really, really fast way. Well, it turns out the difference is this one elegant trick that saves you from scanning your data over and over. Today, we're going to absolutely master that trick, a powerful pattern that lets you solve this whole thing in one clean pass.
So here's our game plan. First up, we'll get the rules of the game straight. Then, we'll look at two different strategies, the kind of basic way versus the optimal way. After that, we'll really dig into the architecture behind that winning approach, we'll trace it live, and then we'll turn it into actual code. And finally, and this is the really cool part, we'll see how this one pattern isn't just for tournaments, you can use it almost anywhere.
All right, let's dive into Section 1, the rules of the game. Before we can even think about a winning strategy, we have to understand the arena we're playing in. So, what are the rules here?
The rules are actually pretty straightforward. First, it's a round-robin tournament. That just means every team plays every other team exactly once. Second, the scoring is simple. The winner gets 3 points, the loser gets 0. No ties, nice and clean. And our one and only job? Find the name of the team with the highest score at the end. That's it.
Okay, so this is what we're actually given to work with. We get two lists, or arrays, that run in parallel. The first one, competitions, tells us who played who in each match. You got your home team and your away team. The second one, results, tells us who won. If the result is a 1, the home team won. If it's a 0, the away team won. Our whole job is basically to connect the dots, to look at the same spot in both lists to figure out the winner for each and every match.
So, how are we going to tackle this? Well, like a lot of problems in coding, there's the obvious way you might think of first, and then there's the optimal way. So let's compare the naive two-pass strategy with the super elegant single-pass approach that we're here to master.
Okay, check this out. On the left, you've got the naive approach. First, you loop through all the matches just to calculate everyone's final score. Then, you have to loop through all those scores a second time just to find out who has the most points. I mean, it works, but it's not very efficient, right? But on the right, that's the senior approach. The key insight, the real light bulb moment here, is that we don't need to wait until the very end. We can keep track of who's in the lead in real time as we go through the matches just once.
So what's the secret sauce behind this awesome optimal strategy? What's the winning architecture? You'd be surprised. It's actually incredibly simple. We only need two key components in our Champions toolkit. Let's see what they are.
And here they are. I'm not kidding. The entire solution boils down to these two simple tools. First, we're going to use a hash map. Think of it as our live scoreboard. Its superpower is that it can find and update a team's score instantly. And second, we just need one little variable. We'll call it current best team to remember who's in first place at any given moment. That's it. That's the whole architecture.
Okay, theory's great, but let's see this thing in action. We're going to do a play-by-play walkthrough of our example tournament step by step to see exactly how our scoreboard and our leader variable work together. This is where it's all going to click.
All right, match 1, HTML versus C#. The result is O, which means the away team, C# is the winner. So first step, we update our scoreboard, giving C# 3 points. Now, since this is the very first match, we check, is C# score of 3 greater than our initial best score of 0? Yep, it is. So C# becomes our very first current best team. Easy enough.
Next up, match 2, C# versus Python. The result is 0 again, so the away team, Python, gets the win. We add Python to our scoreboard with 3 points. But now for the crucial check. Is Python's score of 3 strictly greater than the leader C# score of 3? No, it's a tie, so the leader stays put. C# holds on to the top spot.
And here we go, the final match, Python versus HTML. The result is a 1. So the home team, Python, wins again. We find Python on our scoreboard, they already have 3 points, and we add another 3, bringing their total to 6. Now for the leader check. Is Python's score of 6 greater than C# score of 3? Absolutely. So we have a new leader. Current best team is now Python. And since the tournament is over, we have our win.
Okay, we've traced the logic, we know exactly how it works. Now it's time to translate that blueprint into a real build. Let's see what this looks like in some clean, efficient code. First things first, we got to initialize our two tools. We create an empty hash map called scores and our current best team variable. We'll just start that off as an empty string to handle that very first comparison. Then we kick off our single loop to go through each competition.
And notice this nice, clean destructuring here. It's a great way to pull out the home and away teams in each pass. Now for the magic, the real heart of the algorithm, right inside the loop. First, we update the winner's score. This little +=0 trick is super clever. If a team isn't in our map yet, it just pretends their score is 0 before adding the points. Then, right after that, we do our leader check. This is the optimization. By checking for a new leader on every single pass, right after we update a score, we completely eliminate the need for that second loop.
So what's the big payoff for being this clever? Well, we get this beautiful time complexity of ON. All that means is that the time it takes to run our code grows in a nice, straight, predictable line with the number of competitions, n. We just process each match one time. And our space complexity is OK, which just means the memory we need grows based on the number of unique teams, k. As you can see from this graph, that steady linear performance is a massive win, especially as the tournament gets bigger and bigger.
So, why did we spend all this time on just one tournament problem? Because this was never really about a tournament, was it? It's about recognizing a fundamental, incredibly powerful pattern that you can apply to dozens and dozens of other problems.
You can use this exact single-pass leaderboard logic for all sorts of things. You want to build a real-time leaderboard for a video game? This is your pattern. Need to find the most frequent word in a book or the most common vote in an election? Same pattern. Or what about analyzing data as it streams in where you can't go back and look at it again? This pattern is absolutely essential for that.
Okay, let's lock in the key takeaways from all this. First, anytime a problem involves quick lookups and updates, think hash maps. They are your best friend. Second, if you need to find a maximum value efficiently in a single pass, always use a running leader variable. And third, keep your code clean and readable with modern syntax, like destructuring. Those three ideas together are what make this pattern so incredibly powerful.
And really, that's all there is to it. A hash map to store the scores, a single variable to track the leader, and we solve the whole problem in one efficient pass. It's an elegant solution that is not just powerful, but also really intuitive when you break it down. And now it's a part of your personal toolkit. So the only real question left is, where are you going to use this pattern next?